from Group 2. I will present about the Lab 1, which is the first procedure. At the end of the experiment, the student should be able to investigate the effect of load and feeding length on the voltage regulation in a radial distribution network feeding resistive load. So for the procedure of this experiment, I would like to invite my friend to explain more about this procedure 1.
For experiment 1, single phase radial network feeding a resistive load. First step, we need to connect a phase of supply line and neutral line to one phase of resistive load here. So getting here to here. Second, we close CB1 and CB2. Close. And then we switch the supply offset to load to 25%. Switch here, 25%. And then it should give 1.25 ampere. So we repeat the same step for 50%, 75% and 100%.
This experiment, we should get the value for VS is 129.21 and the value for VR is 125.4, 124.4 for the 25% resistive load. So the current we should get 1.414 for the current for the load current. Okay. We should repeat the experiment for 50%, 75% and 100%, and we get the value here.
Okay, thank you.
Okay, for procedure B, we should repeat procedure A, and that two sections of the line 1 connected in series, and the two sections of neutral line connected in series as shown in appendix B. After that, we record the table, record the result in table 2 in our lab sheet. Okay, so we choose 25%, and the reading is 128.33. For reading 50%, 75% and 100%, we just switch this and we read at the here.
Okay, for experiment 2, we should conduct the single phase radial network feeding inductive and capacitive load. So for procedure A, for the inductive load on the three-phase circuit, the terminator of we should connect the two sections of the red phase and the neutral line. This is the red phase for single line and the neutral line. So the CT connection, CT at the secondary will we short circuit and close the CB1 and CB2. Thus, we should get the answer reading from this multimeter for 25%, 50% and 70% and 100%. Okay. For the procedure B, we should do the capacitive load. The same procedure from the procedure A, but we should change the inductive load to the capacitive load, and we can get the reading from this multimeter. That's all from me. Thank you.
Question. Assalamualaikum warahmatullahi wabarakatuh. The next is experiment 3. First of all, the TP4, TP2, TP3, TP4 must be connected to the midpoint with the red phase. Then we must temporarily disconnect the load switch on the supply, and this is the load. We disconnect it, and then we can get the no load receive voltage here. Then we must reconnect the load back.
After that, we can take the reading starting with 25% and then 50%, 75% and 100%. We can get the VS here, VR here, and then the current here. That's all. Lastly, we must repeat procedure A, procedure B, and procedure C to get the change of inductive load and capacitive load. That's all. Thank you.
Correct. Today we're gonna do lab 2, line model and performances. Experiment 1, short line representation. So first we connect the circuit as shown in appendix A. So right here. So number 2, we shut the CB1 and CB2 we make it open to get the current of roughly 5 ampere. We use the analog voltmeter to measure the voltage drop. Okay. And then you use the multifunction meters to measure the sending and receiving end voltage, current and power. You can also use this meter to show power factor, but for good practice, use equation 6 to calculate the power factor for each end of the line. The sending end voltage should remain fairly constant, determined by your local main supply and cables. Lastly, record your result.
I will present experiment 2. First of all, your procedure, connect the circuit as shown in appendix B. This is appendix B. Then select resistivity and inductive load to 100% and 50%. Then shut the CB1 at the secondary and CB2. Shut the CB1 and CB2, which is closed. Then this will connect the power line. Then use the right hand analog voltmeter to measure the voltage drop across the two inductors at the sending end, and the voltage drop across the two inductors at the receiving end. In the appendix B, the right hand line shows wire to move to make this connection. Use the multifunction meter. To measure the line current, the sending and receiving end voltage. You can also use this meter to show power factor, but for good practice, use equation 6 to calculate the power for each end of the line. The sending and voltage should remain fairly constant. Lastly, record your result in the result template. Thank you.
Hi, I'm going to present experiment 3. First, connect the circuit as shown in appendix C. Appendix C, connect this. Select a 100% resistive and 50% inductive load. Okay, then second, shut CB1 at the secondary of the supply transformers and CB2 at the same end of the single phase line. Disconnect power to the line. Close CB4 to connect the multifunction meter in the lower panel correctly and complete the line. Okay, next, use the left hand analog voltmeter to measure the voltage drop VD across the inductance of the line. Use the analog ammeter, that is this, to measure the capacitor current. Use the multifunction meters to measure the line current, the sending and receiving end voltage, current and power. You can, we also use this meter to show power factor. Okay, lastly, record your result in the table 3. Okay, in our result, we got the capacitor voltage from here, that is 106, while our capacitor current that we got from here is 0.34 ampere. So, and That 0.34 ampere is for 10 shunt, and for 20 shunt is 0.66 ampere. So thank you.
Okay, first of all, for the experiment C, we need to connect the circuit as shown in appendix C. So we have set up the wire, and first we need to check the CB1 and CB2. CB1 and CB2. This connects disconnect power to the line. So close the CB4. Connect the multifunction meter and lower panel connect the incorporate line. This is the multimeter, the multifunction meter. Okay. By use the left hand analog voltmeter, we can measure the voltage drop across the inductance of the line. So we need to use the analog current meter to measure the line current. Sending and receiving voltage current power. We can also use the meter to calculate the power factor, to calculate the power factor. So we need to record the result that we get to the table 3 in this lab sheet. Okay, with that, thank you.